Fourth grade lesson 5.1 is modeling factors. What are factors and how do we show them in a model? So that's what we'll get into. Let's have a look at how this one looks. Okay, our essential question is how can you use models to find factors? And if we aren't sure what factors are the numbers that you multiply together in order to get a product. So 18 times 1 are the factors for 18. 7 times 1 are the factors for 7. 4 times 4 is the factors for 16. 2 times 8 equals 16. 2 and 8 are the factors for 16. So that's how you build those products, is what those are. Here's the definition in words. A factor is a number multiplied by another number to find a product. The answer to a multiplication problem. Every whole number greater than 1 has at least 2 factors. That number and 1, whatever that number is, and 1. So we have the factor of 1, the factor of 18. 1 times 18 equals 18. That's the product. The factor of 7 times the factor of 1. 7 times 1 is the product 7. The factor of 1 times the factor of 342 is the product 342. You have other numbers that can be broken into factors in different ways. So some products have more ways or more factors that they can use. Here's some examples. 1 times 16, 1 and 16 will give you the product 16. So there's 2 factors. But you can also do 4 times 4. So 4 is a factor of 16. And you can also do 2 times 8. So 2 and 8 are factors of 16. So we want to find, the activity has us trying to find all the factors of 24. And we're going to use arrays. And this is going to be really useful because this week we're also supposed to be looking at chapter 13 because it's way at the end of the year. And it talks about area and perimeter. So I'm going to tie this together with the area lesson because it's kind of the same thing. So it'll make perfect sense to you, I think. Use all 24 tiles to make as many different arrays, rectangles, as you can, where everything inside equals 24. Record the arrays in the grid and then write the factors modeled. So here, notice they have, and this is how you find area. Area is all of the inside part of a shape. The area of the shape is all of the amount that's inside. So if I were to count these up, I would get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a row of 12 across the top, and then there's 2 rows of that. And so it's 12 once and 12 twice. And so if we were finding area, we don't want to have to count everything inside of there. That would take too long. We learn that the length times the width gives me the area. Area is going to be the length of the rectangle times the width of the rectangle. Length times the width. And so if we have the length of 12 times the width of 2, then we know there's 24 in there. The factors are 2 and 12. Okay, is there another way that I can make 24? What are some factors for 24? Well, I'm going to keep in mind that up here they said every number has the factors 1 times its own self. So I'm going to use this T-chart to help me kind of guide me through. 1 times what number will give me 24? 1 times 24 will give me that. Let me draw that. Let me see. I'm going to do that down here to give me the most amount of room. So I have 1 times 24, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And so that rectangle is the factors 1 times 24, which equals 24. And that's the area. The length is 24. And the width is 1, so the area of this rectangle is 24, meaning there's 24 squares inside that rectangle. Okay, what else? We already know about 2 times 12, so I'm going to put 2 times 12, and we already have the area of that rectangle. There's 24 inside because 2 times 12 is 24. Length 12, width 2. And 2 times 12 is 24. That's the area inside. Okay. What about 3? Is 3 times anything 24? Exactly. We need it to be exact. Oh, yeah, 3 times 8 is, right? 3 times 8 will give me 24. So let's draw that. We'll have, let's do it over here. 1, 2, 3. And then 1, 2, 3, 4, 5, 6, 7, 8. There's 3 times 8. So we have those factors of 3 times 8. 3 and 8 are factors of 24, of the product 24. And if you were finding the area, how many squares, how many units would be inside of this particular rectangle, we would multiply the length L, which is 8, times the width, which is 3, and that would give us 8 times 3 is 24. And if I counted up how many were in there, 8, 16, 24, it's just a nice shortcut to do length times width to find the area of the rectangle so that you don't have to count up all those squares. In a rectangle, the length of it times the width of it will tell you how many units are inside. So we have an area of 24 because 8 times 3 is 24, and the factors of 24 include 3 and 8. Okay, maybe we can get another one. 4. Let's see. 4 times what number will it give me 24? Oh, yeah, it will. 4 times 6 is exactly 24. So I'm going to do 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. This is 6 length, width of 4. So how many squares are inside of that? The length is 6. 6. I'll write it over here. The width is 4. So what is the area of this rectangle? Well, 6 times 4 is 24. There are 24 squares in there. That's the area. That's how you find area. And so we see then that 4 and 6 are also factors of 24. So we have factors 2, 12, 1, 24, 3, 8, and 4, 6 as factors. And the reason I put this T chart here, for me, my brain likes to organize it this way. I put the product above, and then I start with 1 because I know that's always a factor. 1 times what? 24. And then I go, will 2 work? If it's an even number, then 2 will work. It'll be times something. Then I ask myself if 3 will work because it does on some and not on others. And then 4. And then I notice 5 times something. If I could ask, my next one would be 5 times what number will give me 24. Remember, this has to be exact. In this case, no remainders. But 5 won't work. So then 6 is next, but look, there it is. So it's 1, 2, 3, 4, 6, 8, 12, 24. So it puts it in order for me, all of the possible factors. So that's why I like this T chart a lot when I'm talking about factors. So I have the factor of 1 from here, then 2, 3, 4 are factors of 24. See how they asked for it from least to greatest? Well, our T chart did that for us. Then it's 6, 8, 12, 24. 6, 8, 12, and 24. 2 factors that make the product are sometimes called a factor pair. Factor pair, factor pair, factor pair, factor pair. How many factor pairs does 24 have? It has 1, 2, 3, 4 factor pairs. Factor pairs. Okay, on the Sharon Show, they want us to use these arrays, these rectangles, to name the factors of 12. So they drew it for us. We have 1 row and a length of 12. It's 12 across. If you counted these up, it'd be 12. We almost didn't even have to count it up because we know that it's going to equal 12, and 1 times anything else is going to be 12. So they told us there were 12 in here. So 1 times 12 is 12. That means the area of this rectangle, if you're doing area equals the length times the width, 12 times 1 is 12. 12 boxes, and there's what area stands for. So I have the factors 12 and 1. I'll do it with the T-chart too, just so you can see what I'm talking about. So we have the factors 1 and 12. 1 times 12 is 12. Now we have this array. This is 3 across. We'll call that the length. Remember, I had the area equals length times width. Okay, and then we have 1, 2, 3, 4 down, width of 4. So I have a length of 3. I'm putting a dot, you guys. That's the substitute for multiplication. Sorry, I got ahead of you in a couple of grades. Times. Okay, 3 times 4. The dot, when you get older, multiplication can be represented as a dot too. So that's, I was getting ahead of myself. A couple years ahead of you, by the way. But now you know. So now you know that. When they talk to you about that later, you'll be like, yes, I know this. Okay, 3 times 4 tells me how many boxes are inside. It tells me the area. Okay, so I have 3 times 4 equals 12. So my factors are 3 and 4. They did this over here. We have 2 rows with 1, 2, 3, 4, 5, 6 columns. The length is 6. The width is 2. So the area is 12, which is that there are 12 boxes inside. The whole, to cover this whole section, is 12. And that means our factors are 2 and 6. 2 and 6. I made room for that 2 there because I wanted it in order, remember, because they're going to ask me in least to greatest order. The factors of 12 are 1, 2, 3, 4, 6, and, which is there, and 12. Those are all the factors of the number 12, the product 12. Learning what the factors are will help. We're going to be using this as a tool. So we're going to definitely want to get used to what these factors are, how to find them, how to identify them, because you're going to be asked things like, what's the greatest common factor? And it's going to be a useful tool for you in math over the next couple of years. So first step, learn what the factors are. And so that's what this lesson is all about. What do they mean by factors? Okay, they would like for us to use tiles to find all the factors of the product, record the arrays, and write the factors shown. So we're looking for the product of 5. I'm going to do the T-chart as well. Okay, so let's draw. I could do 1 row and 1, 2, 3, 4, 5. That is 1 times 5. That gives me the product of 5. So 1 times 5. Is there any way I could do 2 and get 5? Oh no, I end up with 1, 2, 3, 4, 5, 6. So that's not going to work. Is there any way I could do 3 and get 5? No, because I'd have to break it apart and they have to stay as a rectangle. So no, 3 isn't going to work. Anyway, I could do 4, 1, 2, 3, 4, and then go this way and get 5 exactly. No, because that's 4, too little. And if I went even further out, now that's 8, too big. So it doesn't land on it exactly. So that's it. And then 5 times 1, which is here already. 1 times 5, 5 times 1, commutative property of multiplication, means either way it works. So the only factors of 5, the product 5, is 1 and 5. That's it. That's the only factors for 5. You'll learn that's called a prime number when his only friends are 1 and himself. We're going to probably get into that in the next few lessons. Okay, let's take a look at 20, the product of 20. How many ways can we do that? I'm going to use the T-chart also, just because I know it's a tool that helps me, so I'm hoping it will help some of you. I'm going to start with the 1, because we know the factor of any number includes the 1 times itself. So 1 times 20. So let's draw that one right off the bat. 1 And then we're going to go 20 across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Ooh, that was long. Okay, that means there are 20 squares in here. The area is 20, and I find area by multiplying the length, 20, times the width, 1. Area equals the length times the width. So the area in this case is going to be 20 times 1, which is 20. Area is 20. That means how many are in here? Sneaking ahead to chapter 13, trying to tie these together because they really do go together. Same idea. So that we have chapter 13 done already. So area was one of the things you learned in chapter 13. Okay, well, so we know the factors of 20. One of the sets of factor pairs is 1 and 20. 1 times 20. Wonder if 2 would work. Let's try it. Let's change colors and we'll do 2 rows. Well, 2 times what number can give me 20? Is 2 times something going to give me 20 exactly? Yes, 2 times 10 will do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 times 10. So 2 and 10 are factors of 20. Okay, so if I were given this rectangle and I was told to find the area of this rectangle or how many boxes were inside this rectangle, I could count them all up, sure, but I could also just say, oh, the length is 10, the width is 2, 10 times 2 is 20, the area is 20. Okay, what about 3? Is 3 times any other number going to land exactly on 20? If I count by 3, is 3, 6, 9, 12, 18, 21. I skip over it. That one's not going to work. I'm not going to be able to get a row in a rectangle 3 and get exactly 20. It's either going to be too low or too high. I can't get it right on. And in this case, we need it to be right on, no remainders. What about 4? 4 times what number will give me 20? 4 times 5 does that. 1, 2, 3, 4. 1, 2, 3, 4, 5. There are 20 boxes in here. 5, 10, 15, 20, right? We have the width of 5. Oh, sorry, that's not right. We have the width of 4 and the length of 5. Area, if I wanted to know how many were in here, equals the length, 5, times the width, 4. 5 times 4 is 20. My area is 20. And 4 and 5 are factors of 20. Now, I know I can stop here. I don't need to figure out the factors of if 5 works or anything higher than that because look, there it is, right? So as soon as you get to that point on your T chart of what the factors are, then you can just kind of loop back around. So you're done. So I have factors are 1, 2, 4, 5, 10, and 20, and they're in order for me already. Factors are 1, 2, 4, 5, 10, and 20. Those are the factors of 20, all of the factors that can build the number 20, the product 20. Okay, the next one we're experimenting with is a product of 25. Well, let's do that T-chart again. Our product needs to be 25, and we know every number has a factor of 1 and itself, which would be 25. 1 times 25. So let's go ahead and do that rectangle. 1, and then I need to go across 25. So there is the 25. I didn't make you have to listen to me count it. The length is 25. The width is 1. If I wanted the area or to know how many boxes are inside this whole rectangle, I would do the length 25 times the width 1, and it would be 25. There's 25 boxes. 2 factors of 25 are 1 and 25. What about 2? Well, 2, if I count by 2, I'm never landing on 25 exactly. I would hit 24, I'd skip 25, and I'd end up on 26 because 2's divide equally into even numbers. 25 is an odd number. It doesn't end in 0, 2, 4, 6, or 8. Even numbers end in 0, 2, 4, 6, or 8, and 25 does not do that. It's odd. So I can't multiply by 2 and end up landing on 25. 3, if I count by threes, look down your chart. If I count by threes, am I landing on 25? I would get 3, 6, 9, 12, 18, 21, 24, 27. I've skipped right over it. So I'm not going to be able to build an array with a row of 3. What about 4? 4, 8, 12, 16, 24. Ooh, so close. And then you're at 28. Jumped right over it. No good. How about 5? 5, 10, 15, 20, 25. Ding, ding, ding. Winner, winner, chicken dinner. 5 will work. So we would do 5. 1, 2, 3, 4, 5. And so there's 5, 10, 15, 20, 25. So I needed 5 as my width and 1, 2, 3, 4, 5 as my length. 5 times 5 is 25. And if somebody asks you, hey, what's the area of this garden that has a length of 5 feet and a width of 5 feet, what is the area inside of that? And you would take the length and multiply it times the width. Well, the length is 5, so it would be 5 times the width, which is 5. And you would say, oh, the area is 25 square feet. Square of feet, okay? So that would be how you find the area. Anyways, though this lesson is asking us only about factors, but again, we're looking at this and tying it together because we'll never get to chapter 13 before your testing time, and I want to make sure that you understand this as well. So this ties together nicely like I've mentioned. Okay, so here are my factors of 25. 1, 5, that's already 5 again, so we don't have to repeat it. So 1, 5, and 25. The factors are 1, 5, and 25. So this is all that lesson 5.1 is about, is getting familiar with factors, getting familiar with how to model them in rectangles, in arrays, and that there's different ways to do it depending on the number. Some have only one way to do it, but other numbers you can do it. In this case, we could do it 2 ways, with the 1 times 25, the 5 times 5. So that's all this lesson is about. So hopefully you find yourself able to identify the factors of different products. Hopefully I gave you enough information to be successful at that. If not, we'll practice some more together.